Hi, everyone. On behalf of the Southeast New England Program Network, welcome to our webinar titled Emerging Stormwater Technologies in Rhode Island, FocalPoint, brought to you by the Stormwater Innovation Center. My name is Leah Soloway from the New England Environmental Finance Center, and I'll be assisting with logistics for today's program, along with Tess Clark from the Syracuse University Environmental Finance Center. Before we get started, I'd like to introduce the SNEP Network. The SNEP Network's mission is to empower communities to achieve healthy watersheds, sustainable financing, and long-term climate resilience through the management of stormwater and restoration projects. We focus on building local capacity by providing no-cost trainings, webinars, and technical assistance to communities in the SNEP region. If you would like to learn more, please visit snepnetwork.org for more information. Before the webinar begins, there are a few logistics to keep in mind. First, everyone will be on mute to ensure audio quality. You'll be able to ask questions by typing them into the questions box on your GoToWebinar control panel. We look forward to answering questions, so please type them in at any time. We have closed captions available for today's webinar. To view the closed captions, please click the link that we will put into the chat. And on that note, I'd like to hand things over to Rebecca Reeves, who will provide us with some background information and introduce our speakers for today.
Thank you, Leah, and thank you, Tess, for all of your help with this webinar. As Leah mentioned, my name is Rebecca Reeves. I'm the Education and Outreach Coordinator with the Stormwater Innovation Center. So for those who aren't familiar, the Stormwater Innovation Center is very collaborative, was developed in collaboration with many different organizations, including the Providence Parks Department, Audubon Society, Rhode Island Nature Conservancy, SNEP Network, among many others. And most of our mission is to provide to the public as well as green infrastructure professionals the lessons learned in the design, implementation, and maintenance of green infrastructure systems. And so we have access to the over 30 stormwater BMPs at Roger Williams Park in Providence, Rhode Island, to help demonstrate these lessons learned. So we will offer both remote trainings, such as this Emerging Technologies webinar, as well as hands-on trainings for green infrastructure professionals, as well as the general public. Working with the general public, we have things like community festivals, monitoring initiatives, as well as stormwater in schools programming. So that photo on the bottom left, you can see some of our stormwater in schools mural design. We have a community volunteer looking at cyanobacteria in the middle, and on the right, we have a photo from our recent Stormwater Innovation Expo done in collaboration with the Green Infrastructure Coalition in Rhode Island. So we can go to the next slide. So I'll go ahead and introduce the presenters for this morning. If you're interested in reading full bios for our presenters, you can do that at the link that's listed at the top of this slide. So first up, we will have Christopher Dill, who's with the Rhode Island Department of Environmental Management, who will be talking about the approval process for new stormwater technologies in Rhode Island. And then we will hear from Scott Gorneau and Rob Woodman, who are the manufacturers of the FocalPoint biofiltration system. Then we'll hear from Mark Hollis, who's with Deprete Engineering, about the construction process of FocalPoint systems. And then we will hear from Larry Colantuono, who is with Safe Harbor Wickford Cove. This is one of the places that has installed the FocalPoint system. So I will go ahead and turn it over to Chris Dill first up.
All right, thank you, Rebecca. I'm just waiting to share my screen. All right, and is that showing the full presentation now? Yep, okay. All right. Get this out of the way. So good morning, everybody. I'm Christopher Dill. I'm with the Rhode Island Department of Environmental Management, and I'll be briefly going over the proprietary stormwater treatment technology approval process for Rhode Island. The Rhode Island Technology Review Committee is responsible for reviewing applications for proprietary stormwater technologies, and this consists of DEM, DOT, and CRMC, which is the Coastal Resources Marine Council. From DEM, we have Eric Beck, Nick Pisani, and myself. I'm the contact person for the proprietary technology information. We also have Elisa Richardson from DOT and then Ross Singer from CRMC. So we have 3 types of stormwater technology certifications for proprietary devices in Rhode Island. Start out with retrofit devices. This is for basically just improving old sites that have existing problems with flooding or water quality, that sort of thing. Not really a new development or a redevelopment, but like I said, just kind of fixing an existing problem. And we offer a little bit of flexibility on these sites in terms of our minimum standards and the BMP performance criteria. BMP meaning best management practice, or a stormwater treatment unit. And we're looking to ideally capture and treat at least half of the water quality volume, which is associated with 1 inch of runoff. Then moving on to pretreatment devices. These are primarily used to concentrate where the maintenance for BMPs would be located and sort of act as a first wall of defense for protecting the main BMPs themselves. So this might be like a hydrodynamic separator or a sediment forebay before you have your main infiltration basin or primary BMP, and you're trying to prevent that from getting clogged as quickly. And they can also be used as retrofit devices. We used to allow them to be used for oil water separators if they were big enough, but that's no longer allowed. And then moving over to water quality BMPs, which typically require pretreatment. We have some standards in Rhode Island, so we need 85% removal of total suspended solids, 60% for pathogens, and then 30% for nitrogen and phosphorus. And vendors can also provide, additional testing to show that they can get higher removals rates than those that we require, and also removal rates for things like metals and other pollutants like that. And then down at the bottom of the screen, we have the link to the application form that vendors have to fill out and submit for their applications if they want to try and get an approval for a proprietary technology in Rhode Island. So moving on, this is the certification process that we have. Starts out with a vendor getting third-party testing for their device. I'll explain what tape and tarp mean in the next slide. And after that, the vendor fills out the application form and submits the necessary materials. The Technology Review Committee reviews it. There's an optional presentation, which usually happens from the vendor. We evaluate their submittal and we'll issue comments or request additional information if that's necessary. And then once the vendor adequately satisfies that, if they're able to, we finalize the certification and kind of make sure everybody's on the same page with that. And then we issue the certification, which is valid for 5 years. And from there, we have training sessions like we're having today. Initially, we'll hold it for the review staff in Rhode Island to make sure that we're all reviewing it in a consistent way. And then we'll also hold trainings for designers, municipalities, and eventually maintenance providers. So what is TAPE and TARP? TAPE is the Technology Assessment Protocol Ecology that's ran out of the state of Washington. And they have a really thorough program for evaluating these technologies. And in order to get certified as a water quality BMP, you need either TAPE certification or providing third-party testing that's essentially on par with those requirements. And if you look at Appendix J of the Rhode Island Stormwater Manual, you can find more information about that. And then TARP is the Technology Acceptance Reciprocity Partnership, which kind of fizzled out, but it was initially consisting of about 6 or 7 states that were all trying to, work together to certify technologies. And another honorable mention would be the New Jersey Department of Environmental Protection. They have a pretty rigorous lab testing program for pretreatment devices, so we also accept that as well for the pretreatment. Once vendors get their certification, they have various reporting requirements, relating to how many systems are installed, where they're installed, any system failures or changes to the device, transfer of ownership. And also applicants can request a recommended maintenance schedule after the first year, because sites can vary with pollutant loading quite a bit. So it's good to kind of take a look at what you get after the first year. Like I mentioned earlier, we have the certification is good for 5 years, and then if the vendor would like to get recertified for that device, they need to have the adequate reporting that I mentioned previously. They need to have that for the last 5 years, along with any additional studies or testing, certification, stuff like that they might have gathered over that 5-year period. And the device still has to meet the pollutant removal requirements. So say one of those reciprocity certifications gets revoked, then that could affect their ability to get recertified. And if you go to the DEM stormwater permitting page, which I have right here, I'll click on that. You go to stormwater technologies, and I'll actually open up the certification for the FocalPoints so that you can all see that. So this is the DEM stormwater page. You go to stormwater technologies. Now that will download the list, open that up. Just give it a moment to load. There we go. And here are the approved devices. So these are the water quality BMPs. Then we have proprietary and pretreatment devices. So you go over to the FocalPoint, click on this hyperlink right here. And that brings up the certification, gives you all the contact information for the vendor, kind of explains how this ties into the Rhode Island stormwater rules, and mentions all of the testing that they did to accomplish this. And also a brief description of the technology, mentions the removal rates that it has, and then various design criteria. So for this product, it needs to have some form of pretreatment for it. Rob will get into that in his design overview. And then you can just see here other requirements. So here it's certified as a water quality BMP, and this is how it must be designed. We also have maintenance requirements, reporting requirements, and then rights. You can see Eric's signature down there. These are the various plants that it can be used for the FocalPoint, and we also mentioned a little bit about the sizing in that in this requirement right here. So I'll get back to my presentation. So that's about it. That's all I have. So we'll open it up to questions now if anybody has any questions.
Thank you so much, Chris. Yes, please send your questions in the question box at any time. We'll have about 5 minutes in between each presenter for that, and also 10 minutes at the end for anyone. There was one question that came through. I think that's the only one we have time for at the moment. Are the pollutant rates, removal rates, required bench rates or real world testing rates, e.g. tested somewhere like UNH's stormwater testing lab?
Yeah, so we look for actual testing. For the BMPs, we look for field testing. And for proprietary, or for, pretreatment devices, we allow for laboratory testing, which is what New Jersey is currently doing for pretreatment. But for the water quality BMPs, which the FocalPoint falls under, that requires field testing.
Thank you so much. All right, I think just an effort of moving things along on the schedule we have, we will switch over to Scott and Rob's presentation on the manufacturers of FocalPoint. Thank you so much, Chris. There will be more time for questions at the end if you have more of them. Please send them in.
All right, well, good morning. Everyone see those slides now? Awesome. All right, well, thank you for having us this morning. My name is Rob Woodman. I'm a professional engineer and I have a few other certifications, and I have this pretty awesome job of leading Ferguson Waterworks as the National Manager for Urban Green Infrastructure. And I'm joined by my friend and colleague, Scott Gorneau, who is the Vice President of Innovation with Convergent Water Technologies. Scott is going to be managing the questions that come in and any kind of chat content. So definitely fire off questions as we go along, and he'll try to answer them. And I know we'll also have some time at the end. Thanks for the lead-in for all the folks who put this together. Chris, great overview of the program, and it's certainly been a pleasure to work with RIDEM as we work through the FocalPoint approval process or certification process, and really one that's quite unique. And I'm going to point that out a little bit as we go through today. We've really found it to be a really good process, and there's a couple of key reasons why that I'll touch on. I'm going to be spending about the next 45 minutes, so right up to about 10 o'clock, going through the FocalPoint biofiltration system. I'm sure some of you have seen the system or heard of the system. Maybe some of you have designed with this system, and there's probably a lot of people on here where this is completely new as well. So again, if you have any questions, fire them off and we'll address them as we go along. Scott and I do what we do because we are seeking to protect the natural resources that we have to enjoy. You see Scott catching a whopper of a fish out in the Casco Bay area on his little boat in Portland, Maine. It's me with my wife and kids at Sebago Lake, or on Fry Island, Sebago Lake, Maine. We're both residents of Maine, and have a fun of ton working on a national scale, trying to solve challenges in this ever-changing and evolving world of, stormwater management, wet weather management, climate change, resiliency, and all these different things. But while we get to see a lot of things that are happening all over the country, it's super fun for us to be working right in New England, where our families live and are growing. And just to kind of highlight the relationship as well, so Convergent Water Technologies are the innovator and manufacturer of the FocalPoint system. Ferguson Waterworks is the distributor or the seller of that system, and we also provide all of the engineering technical support that goes along with incorporating the FocalPoint system into projects. Ferguson itself, a national company, a large footprint, about 33,000 associates. And I just throw it on the board just to show that we've got some pretty big coverage there, and also have the ability to service projects in a very local way via all the different branches that we have and the experts we have on our team. We work with all kinds of stormwater solutions, and I think one of I feel like our superpowers as a distributor is that we can kind of look at all kinds of different systems that are out there and kind of pick and choose different parts and pieces and come up with really interesting systems. And you're going to see some of that today when it comes to having the pre-treatment and some expanded storage potential, as well as bypass protection and things like that. No matter where you go, everyone's trying to do more with stormwater, trying to fit stormwater into places where it previously wasn't located, and we just had conveyance. Now we're trying to, when we look at these green streetscapes and things like that, we're space limited, and we're trying to do a lot more with stormwater, treat larger events and things like that. And Scott, I think I can hear you type in there a bit. You want to mute there? Thanks, mate. Cheers. And each city has their own take. So no matter where you go, whether you're in any of these bigger kind of green infrastructure cities, Philly, New York, DC, Pittsburgh, everyone's trying to come up with their ways or different ways to manage their wet weather, most often for volume, but in some cases for water quality also. But when you get into these urban settings, there's a lot of complexities that come along with that. So, you're dealing with tight spaces. That's probably the number one thing. Just not a lot of room left on a site to manage stormwater. You might be working around existing infrastructure, other kinds of conflicts. You might be affecting local business, and kind of in the municipal retrofit world, we've got to think about, okay, what's the short-term and long-term impact with digging up a certain portion of the street and putting some kind of system in. And then what I'm continually trying to remind people is it's not about just digging a hole, throwing something in the ground and moving on. There's a need to make sure it's actually working, maintaining it, right, on a regular basis to make sure that these systems are thriving. And then there's that balance too, right? It's not just about processing or storing stormwater, but hopefully we can actually make these systems look good as well. And that's a big focus of ours, is to try to balance that function with feature. So essentially what we've sort of built out over the last 6 to 8 years, and Scott and I have collaborated very closely on this in past roles and now in our current roles with Scott at Convergent, myself at Ferguson, is trying to come up with a suite of solutions that's space efficient, probably number one thing. Versatile and flexible is also really important. High performance, in this case today, for a water quality standpoint. Sometimes that's for structural loading and different things, depending on what kind of product you're looking at. Easy to maintain, right? Because maintenance does have to happen. So let's try to make it as easy as possible. Cost appropriate. And then think about how can we extend the performance of some of these systems to address some of the challenges related to resiliency and climate change. And then just a little tidbit, and we'll touch on this a little bit throughout the presentation. One of the things I keep seeing, one of the biggest challenges I keep seeing in urban green stormwater infrastructure programs or retrofits ties back to maintenance. And we keep finding this theme of, hey, if you can put in better pre-treatment or upstream filtering and screening, we can probably help that system last longer and continue to perform moving forward. And what I love about this is not only do I see this all over the place, but I really like that locally in Rhode Island, as we were going through the process with FocalPoint, one of the key parts of the certification is that pre-treatment is required. And we loved that that was the case, because in so many states, it's kind of optional. It's not really regulatorily required. And if it's not regulatorily required, most people choose not to put it in because of the cost piece, right? But we found the better job you do with pre-treatment, the more you can extend the performance and life of a system like a FocalPoint, and also reduce the cost and frequency of maintenance. So pre-treatment's a big deal, and Rhode Island certainly knows that. So again, balancing function with feature, right? So the FocalPoint, as you'll see today, allows it to fit into small spaces, functionally process, treat, and manage stormwater, but can also look pretty sharp too if it's done well. So we have 4 categories of solutions: storage, filters and screens, media and biofiltration, and then also alternative surfaces. But for today, we're really just focusing on media and biofiltration. We'll talk a little bit about storage as we go along, because there's a modular storage component of the system that allows us to manage volume as well as just the water quality processing of the FocalPoint. All right, so let's dive in. So the FocalPoint biofiltration system. The FocalPoint, as you can see in some of these images, small footprint. It's a modular high performance biofiltration system. We're using 100 inch per hour media. And for those who aren't familiar with kind of rates of media, that's a high flow rate versus a typical sort of bioretention or rain garden system that might process at, say, 2 to 5 inches per hour. So we're treating at a really fast rate. We're providing treatment for a variety of pollutants, which we'll touch on in a minute. And we've gone through and been very diligent in our testing to make sure that we've got approvals and certifications in all of the northeastern states and others too, but I just wanted to highlight those today. We also meet all of the MADP CONCOM requirements for using innovative practices, as well as the BWCS or SC regulations for phosphorus as well. So really useful to a lot of different types of projects up in the Northeast. To tie back to what Chris was saying about what kind of testing is needed, we've gone through a full-scale third-party field test to tape standards, and then we've also more recently gone through an NJCAT, NJDEP process to get verified and certified as a green MTD for folks working in New Jersey. That's less relevant for this presentation today, but we've been working hard on doing all that testing in the background. If we tie back to Chris's slide again, so from a RIDEM standpoint, we're a certified pretreatment device, a retrofit device, and a full water quality BMP, achieving the 85% TSS, 60% pathogens, and then the 30% for either total nitrogen or total phosphorus, depending on what kind of watershed you are in. But the cool thing about going at a fast rate is when you speed up that rate of processing stormwater, it allows you to shrink up the footprint considerably. So the FocalPoint's usually only going to be about 8 to 10% of the size of a typical surface green infrastructure practice like bioretention, rain gardens, and other types of organic filters. When you have a smaller footprint, you have less disturbance, which is really helpful, specifically for retrofit or digging up some kind of city street to do some stormwater stuff. You don't need a lot of space. It's got a smaller maintenance footprint, so that's nice. So it's a smaller area to have to deal with on a regular basis. And then what I love is that because that has a smaller footprint, you could now actually go back to locations that you maybe previously overlooked, because maybe you went to another site and were like, oh, we'd love to do a bioretention system here, but it's going to fill up half the soccer field on a school project, or oh, there's not enough room between these two driveways on a city street to treat the full inch. Well, now with FocalPoint, you can go back to those spaces and say, oh, you know what, we can tuck this off to the side of the soccer field, or we actually can treat the full 1.2 inch rainfall event between these two driveways using a FocalPoint. So it gives you that ability to go back and consider those locations. And obviously, certainly on tight sites, which are highly developed, it gives you the opportunity to manage stormwater in a very space efficient way. So let's take a look at the section. The FocalPoint is a vegetated system. So we do require plants for that ongoing uptake of that nutrients, which they want. Chris mentioned in his little introduction there that there is a list of plants that we have specifically for Rhode Island that you can pull from. We have recommendations for what types of plants, and in the case of Rhode Island, there's a list of those, about 8 plants. And then we also have recommended spacing for those plants. We don't provide the plants, but we provide that guidance and can help review that when projects come through. We don't generally put trees in this system. We really haven't seen trees do particularly well in these high flow systems, some of the early kind of tree box filter type concepts. And it's a media that's mostly sand and fine stone, and then a small amount of peat hair for organic. So it's not that deep, rich planting soil that a tree is necessarily going to thrive in. So we generally go with smaller perennial plants, switchgrass, black-eyed Susan's daylilies, these types of things that are going to do well in the droughtish periods, but then also be able to handle the heavy inundation also. So we can help with that. But the cool thing, again, you've got a small footprint. So if you're like, oh, well, I really wanted trees, well, you can put trees immediately outside of the system in a nice, deep, rich planting soil where those trees are going to really thrive and become part of that overall aesthetic for your site. Underneath the plants, we have a layered system, and we provide all the components from the mulch all the way through to the underdrain, and it's sold on a per square foot basis with all the components delivered to the site for a fixed price. So we start with a 3-inch layer of hardwood shredded mulch, hardwood and diligently screened so it's less susceptible to floating, and also we don't want to have a mulch with a bunch of fines that are going to clog that surface. So it's a well thought out mulch. That mulch actually really grabs and traps a lot of that sediment load if you don't have good pre-treatment upstream. So that's really your focus of maintenance, is removing the mulch and putting it back from time to time. And I'll show you some slides on maintenance a little bit later. Then we go into 18 inches of a high performance media. That media is what's flowing again at that 100 inch per hour. Great pollutant removal efficiencies. You'll see here, these are our actual tested efficiencies. But for our RIDEM, these are the numbers that are awarded. So again, 85% TSS, 60 for the pathogens, and then 30 for phosphorus when you're in freshwater, and 30 for nitrogen when you're looking to put a system in a tidal water condition. So great high removal efficiencies in that small footprint. After we get through the media, we go to a layer of 6 inches of bridging stone. We don't run typical fabrics through this system because those are a known source of clogging of fines over time. So we go directly from the media to this bridging stone. And we provide the stone for 2 reasons. 1, so it's truly a clean stone. And then 2, so that the media sort of nests into that stone. We want the materials to pair well together so you don't have the media falling down through the stone. That's traditionally why a fabric would be used there, to create that separation. But we're doing that without a fabric. Underneath that stone, we have a layer of green mesh. It's called microgrid. I'm gonna hold a little piece up on the screen with a quarter for size of reference in terms of opening size. So it's a small Vaxio geogrid that can be used under that stone, and that's really just to stop the stone from falling down into our underdrain. So we use a modular box underdrain. This is called the R-Tank. Some of you may be familiar with this. I'm going to take a little turn to just chat about R-Tank for a second, because it's important to understand what R-Tank is so you can understand what benefit that brings you with the FocalPoint. So again, R-Tank, let's touch on that, and we'll come back to FocalPoint. So So our tank is a 95% void space modular subsurface storage system. 95% voids means we can minimize excavation, maximize storage. With a high void space, we can overcome shallow groundwater, work around unexpected utilities because it's a modular system. And we're generally using this for detention and infiltration. So for FocalPoint, it creates a really nice, high efficient underdrain. But the FocalPoint itself is really just providing water quality, and most of our projects also need some quantity control. So we can drop straight through that FocalPoint into the R tank, and the R tank now becomes our volume component to the design. We have different modules available, all different heights from 9 inches all the way up to 7 feet, and different strength ratings for different minimum covers. With FocalPoint, we're generally using our heavy-duty module. I have a mini tank I'm holding up on the screen here, if you can see my camera. It's important to note when we talk about things like singles and doubles and triples. I'm holding a double. The double has a common mid plate, so it's made as one monolithic matrix of plates, as opposed to having individual components sliding around on top of each other that you have to line up. So just a little tidbit there. But again, we get this modular versatility, and it pairs really well with the FocalPoint because FocalPoint's small system that's very flexible in shape and size. We can also mirror that with an expanded storage system beneath. So we can really tuck these into weird and wacky spaces and get a lot of storage done. So again, FocalPoint, awesome treatment, maybe off to the side of the parking lot in little traffic islands and things like that. Drop down, and then we can expand this R tank, being traffic load rated, back underneath adjacent parking. And while we've done a lot of work with detention and infiltration with the system on its own, we're now starting to see this kind of creative application space where we can enhance storage under permeable pavers. We can put them in linear green streetscapes, under bioretention, or in the case of today's conversation, create a really interesting volume module that can go directly underneath the FocalPoint. Where do folks use these? Tight spaces. Where do they use FocalPoint? Tight spaces. So we're starting to see a common theme with why these systems kind of work together. And again, being modular in nature, we can do some really interesting systems working with, say, this is a project in Pittsburgh, steep streets and kind of needing to terrace groups of tanks to kind of work with that changing grade at the surface. Great way to provide that storage. All right, so that's our tank. So let's go back to FocalPoint right now, okay? So FocalPoint, when we're just doing water quality, we've got this very small footprint, somewhere between 2.5 and 3 feet in depth, and we can just pipe it downstream. Maybe that's going to a larger system, whether that's chambers or tanks or a pond, a dry pond, who knows what. But if we want to provide storage directly underneath that FocalPoint, we can do that. You can see that in the images here. So small FocalPoints again, tucked over to the side in little islands, drop down, but now we can expand the storage back underneath parking. So it really allows you to kind of maximize your development opportunity in terms of how much impervious area you have and things like that, what your building footprints look like. But it also allows you to fully meet all of the stormwater regulations. So sure, a surface detention pond is always going to be less expensive than anything subsurface. But on these tight urban sites, again, small FocalPoints drop down, larger R tank. So again, we can have small FocalPoint media footprints off to the side, expand our storage back underneath. And I would say, and Scott, maybe you can nod to agree with this, but probably half the projects we do are just water quality and we pipe them out. And then the other half, there's that volume piece, and that's where the R tank comes in. We've also done projects where there's a couple of FocalPoints around a site, or go into one centralized storage system. Or again, you can do the storage directly underneath with their own independent outlet control. The other thing about FocalPoint that I haven't mentioned yet is that it's a boxless system. So that keeps our cost down compared to some of the other proprietary systems on the market. But it also gives us a lot of flexibility in design. So there's not specific sizes of FocalPoint systems. You can do the math, and we'll talk about the sizing in a minute. But you can really come up with an exact size that you need and not have to buy any additional material that you don't need for your site. It comes in components to the sites. We've got bags of media, bags of stone, bags of mulch. We'll talk about pre-treatment in a minute. And it allows you to create really interesting shapes. So it doesn't have to be a perfect rectangle. As civil engineers, we love really nice 90-degree corners on shapes. It doesn't have to be that way though, right? So we can do interesting shapes, kidney bean shapes, kind of work with a landscape, and again, make it more of a feature than just a functional rectangle of mulch with some plants in it. Installation is pretty straightforward. You dig a neat hole. We provide about an extra 15 to 20% material. So you don't want to dig some huge hole that you don't necessarily need, but site contractor digs a neat hole. I should also say that you don't have to be a certified installer to put this in. So we work with any site contractor. We actually provide oversight in the field. So someone from either Scott's team or our team would be out there in the field just to coach the contractor through and get it all done right. We wrap the sides with a basic fabric for separation, place the modular boxes, wrap them with that microgrid material, kind of like you're making a bed across the top and down the sides, and flare out or tuck under. Then we bring over the super sack of bridging stone, place 6 inches of stone, 18 inches of media, and then we finally put on the 3-inch layer of mulch. And then what we'll do is temporarily cover it with a heavy fabric. And we call this cap and seal. And it's sort of a trendy way of just saying, hey, look, we don't want to compromise this system while the upstream watershed is not stable yet, okay? While there's sort of denuded slopes and sediment and grit that could get in. So we cover it with fabric. Then once the slopes are established, vegetation's in, roads are paved, all those things, you come in, cut open the fabric, take that away permanently, and that's when the plants are installed. We have some projects, like larger scope projects, where they might stay covered for over a year or through a full winter and then get planted in the spring. We also do some retrofit work on the muni side, where they may be able to do it all in one day and stabilize the slopes with sod or put some river stone down and plant it that day. So it may never have to get covered. It just depends on the dynamics of your project. Sizing. So I'm sure a lot of you are like, okay, so you mentioned it's a small footprint. What does that actually mean? So essentially what we're doing is we're taking advantage of our dynamic modeling, right? We're modeling this 100 inch per hour throughout the storm event. So if we think about a very typical or a standard hydrograph, early on in the storm, the peak flows are pretty low that are coming into the focal point area. So the focal point can keep up with it. So we're processing all that water as it comes in. There's really no need for surface storage at that point. However, when we get to the peak of the storm, now there's this point where the flow coming into the system is starting to exceed the flow rate that the focal point can drain. And so we do have a little bit of temporary storage, usually at 6 to 12 inch depth, sometimes as high as 18 inches. We just got to think about plants and how long that water is going to sit ponded for. And then as the storm progresses, we get back through to that flow through device. So we're never statically storing the entire volume under that hydrograph at the surface, because we're processing it as we go. And we have some really nifty little HydroCAD nodes we can use to model that. We're going to go through that before we finish today. Okay, so sizing. We have a minimum sizing ratio in Rhode Island that we start with. So that's 192 square feet of focal point for every acre of tributary area. So, if we think about the 10 by 20 parking spaces, it's basically like a parking space being able to treat an acre of parking. So it's a really nice small footprint, easy to tuck in. That's our minimum filter bed size. So we do actually run a model to make sure that based on the temporary storage we provide at the surface and that focal point footprint, that we can fully process the entire water quality event, which is the 1.2 inch rainfall event for most projects in Rhode Island. If for some reason when we run that event, our bypass gets activated prematurely, we can do one of two things. The low cost option is to find a little bit more surface storage at the surface, so we can sort of draw down that peak elevation a little bit and prevent the bypass. Or if there's absolutely no more room to create a little more temporary storage, we can actually expand the focal point a little bit more beyond that minimum ratio of 192 per acre. So we're going to go through an exercise in a minute. You'll see that. And what we found is if you've got 3 to 1, 2 to 1 slopes coming out of that focal point area, it generally works. However, as you start getting more and more vertical, if you have sort of vertical drop-off curves and things like that, sometimes that's where that minimum ratio needs to be expanded out a little bit. So that's water quality. And then when we have to manage volume for a variety of uses, that's when, again, that focal point can have an expanded R-tank system that goes out over a larger footprint. We have a really nifty worksheet for Rhode Island as well, so you can work through things step by step that kind of follow the guidance given by the certification that Christopher was mentioning earlier. Going to work through that process. It lists the plants, shows you how to do some tips on the HydroCAD piece. And we've got a great stormwater engineer in New England. Lauren Joyce is his name. He can also help you work through that as well and kind of help you on the first few while you're kind of getting your bearings to make sure the modeling output is correct. We also are required to produce design review letters as well. So if you're working on a FocalPoint system, again, reach out to us and we can provide a review and then a letter that you can submit over to the review team on Rhode Island side to show that we've kind of looked at it and it seems like everything's being done in accordance with not only the Rhode Island DEM certification, but also our standard specs and installation and things like that. Accessories. So there's a couple of accessories that we often recommend with FocalPoint, but to take a step back, we think about curb line green infrastructure, and that's really what FocalPoint is. It's generally going to be pretty close to the curb line. Sometimes you've got a little bit more space and things like that. But when we think about green infrastructure, rain gardens, bioretention, FocalPoints, we really want them to look good. We want them to filter pollutants, so provide that high level of pollutant removal. We love them to be maintenance free, but unfortunately, that's not the case with any kind of thing in life. Cars, relationships, green infrastructure, it's all the same thing. You got to work at them. But then we also can send this full layer of sediment and trash to these systems, and that creates a bit of a conundrum. If we don't have pre-treatment, we're potentially compromising plants by washing them out. We're potentially clogging filter media, so it goes into bypass more and doesn't treat as much water as we think. And if we send all that sediment to the surface of the focal point or rain garden or bioretention, maintenance becomes a little more tricky now, because now you're kind of hand fossicking for sediment all around that system. So we found that pre-treatment's pretty important to this equation. And the great thing is, like I mentioned earlier, is that Rhode Island DEM agrees with this, which is fantastic. So we got to dissipate energy, we've got to collect sediment debris, but oftentimes we don't have a lot of room to do it. And unfortunately, curb line systems, while they can look good on plan and in awesome artistic renderings, after a couple of good rain events on a city street can look pretty nasty. Obviously, the civil engineers think this system's working awesome. Look at all that trash it's collecting, fantastic. While the public and landscape architects aren't too sure. So we have two options as part of that menu of pre-treatment options that are required for a focal point with Rhode Island DEM. One is called the Rain Guardian for up to 1/4 acre. And then we also have the Pretex, which is up to 1 acre of pre-treatment. So two different options depending on where it's located and the type of watershed and type of sediment you're expecting. The Rain Guardian, again, this is a required element for small watersheds going to focal point. It's a small precast unit. I have a little 3D printed model on my screen here. If you look at my cameras, we have a top grate, you can see on my slides as well, and then a vertical filter wall on the backside too. It's about a 10-inch drop from edge of pavement to the surface of your focal point. And this is just a place where you can dissipate some of that energy, collect some of that sediment in a single spot, and now hopefully make maintenance more about cleaning this Rain Guardian than focusing on cleaning the focal point. So it's a great way, hence the name, to protect or guard that primary asset that you have. This one's called the Turret. It's the circular one. There's a rectangular version called the Fortress, and then one that crosses a sidewalk called the Foxhole, which has all those same components: horizontal screen, vertical filter wall, but it also has a solid cover on top, so you can actually cross a sidewalk and not interfere with your pedestrian and bikeway. A lot of folks use trench drains here, but the Foxhole kind of adds those filters and screening elements in there that make it a little bit more functional from a pre-treatment standpoint. So that's great for small watersheds. When you get into the larger watersheds, Convergent Water Technologies, Scott's company, has a product called the Pretex. The Pretex, as you can see now, is a deeper sumped module. So it's generally a 5x5x5 box with a 4x4x4 inside, a suspended baffle, a weir, and then a screen on the backside. So now you get your full sump, a little bit for floatables, oils, and grease, additional sediment storage capacity. So in theory, you can store more and hopefully maintain it a little less frequently because you have more of that capacity. And there is a unimpeded bypass across the top as well in case this initial chamber gets completely clogged or full. You can see that in practice here. So again, same kind of functional idea. The idea is to drop that energy out, drop the sediment out, and hopefully send relatively clean water to the focal point for polishing, essentially, for nutrients, bacteria, and things like that. And again, those two items, depending on the size of your watershed, are part of the Rhode Island DEM approval, which again, we were thrilled with because I think pre-treatment's really important. And like that in Rhode Island, that is valued in the same, at the same standard. And then the last little accessory, It's one thing to treat the water quality event, but what about larger events? So most of these types of vegetative practices have domed overflows to take those larger events. Unfortunately, that's where a lot of floatables and mulch and things like that can end up and eventually get down into whatever you have downstream, whether that's our tank, small diameter pipes, whatever it may be. And so we do outfit our domed overflows with a simple filter bag. It's a permanent filter bag that will now collect any of that material that gets through. So generally with our FocalPoint systems, and you'll see it in some of our case studies, we have that rain guardian or pretext at the curb line. We go into our FocalPoint for treatment, maybe have expanded our tank if you need to manage volume. And then that bypass has one of these filter bags in it. So you get this kind of space efficient, high performance, easy to maintain treatment train that is going to hopefully be pretty easy to own. Maintenance. You guys still see me okay? Yeah. Okay. I'm getting weird notifications. Okay, thanks. Maintenance, pretty straightforward. So maintenance, you're removing and replacing the mulch from time to time. And that's, the frequency of that really depends on the location. It also depends on what kind of pre-treatment you have in place. And you can see here, this rain guardian doing the work probably could have been cleaned out a little bit earlier, but we're stopping all that material from getting through to the surface. Examples, curb line retrofits, easy to do. Here we actually converted an existing catch basin into the domed overflow and built the FocalPoint around it. And we had all kinds of different utility connections to that drain that we had to step in and around. That was one of the earlier projects from probably 7 or 8 years ago now. Simple, this was a parking lot expansion project, looking at pave paradise and put up a parking lot in the entire parcel. This went out of FocalPoint in this island area. And then there was 440 R-Tank mini modules. Those are about 9 inches high, back underneath the parking for infiltration. This one was actually in Massachusetts. But the cool thing is, look, you'd need that island there anyway. So the fact that we could use that for stormwater was pretty useful and didn't really reduce the number of spaces this parking lot had. Different ways to border them. So they don't have to look a certain way. Not all focal points look the same, which I really like. Again, not a perfect rectangle. We're not in a box. So we can do, riverstone or riprap, or this one in Texas, they actually embossed in the curb how many gallons were being managed or treated from for a public education standpoint, which is kind of cool. Here's one in Pittsburgh, and you can see they're planting the FocalPoint in the back, but there's still trees here, but those trees are adjacent to the system in that deeper, richer planting soil, so that'll thrive. Car dealerships, great option, right? We're trying to maximize car display area. Assuming there are cars to sell. So we have, small focal points in these types of islands. High profile retail, this is one of the first ones we did, is at Kittery Trading Post. It's been in for probably 8 years now. Sheet flow was already coming, or there was runoff already coming to this corner where there was a catch basin. We converted that catch basin into a solid cover manhole, opened up the curb with a rain guardian, domed overflow with a filter bag, and then a FocalPoint was built. This is kind of its evolution over the years. You can see Public Works installed this one. They got a little carried away with riprap, but that's okay. And now they're displaying tractors in that area, which is interesting. Dense residential development. Here we have a single-family home that was demoed, and they built this 44-unit housing complex on a postage stamp lot. Still had to meet all the stormwater requirements. So in this little corner here, you can see it here. There's a 33 square foot focal point. And then there's expanded R-Tank doubles back underneath all of this concrete area for not only infiltration, channel protection, also flood control. It was built by a civil engineer, as you can see, or designed by a civil engineer, 3x11 box, perfect corners, but then collaborated with a landscape architect so that we got some really interesting plantings in that system. And nowadays it looks really good. What I've found is when you have smaller footprint systems, you can often fold them into tighter spaces. And so when you can, and even more prominent locations versus the old stormwater system you'd kind of toss out back. And when you put them in more prominent locations, I found that generally they get looked after better. Here, the tenants look after this rain garden. I think just even not even knowing what it is really, but they want their front entrance to look sharp. This is a great little example of an urban project. Focal point off to the side of a paved parking area. Runoff comes through the rain guardian, hits this focal point. Not the most attractive looking focal point, but if you look at the plan, this is where the secret sauce is, right? So you've got this focal point off to the side, treating all that runoff, but then the treated and the bypass go into our tank single plus minis, which are about 2.2 feet in height, back underneath that pave area. So that's really, again, where you can leverage a system like this and still do everything you want on a development. And we've seen some really interesting things from designers, sheet pile terraced walls, raised planters to work with shallow inverts in the street and pick up roof gutter lines. There's a lot of flexibility as a boxless system. We have a system at the ASCE headquarters in Reston, Virginia. We did a kind of walk the talk project down there and incorporated a number of our products. You can see the Rain Guardian here feeding this focal point. Now you'll see there's a lot of space here, but there was about a 5-foot grade change from this sidewalk to this one. So all the retaining and grading that would have been needed to level an area for bioretention, it was way more cost effective to build just a small focal point, have this little river stone channel, as you can see it here, feed that focal point, kind of work down the grade. Local projects, in New England, we have a lot of projects where we're close to groundwater, and so we need to use an impermeable liner. In fact, a lot of our systems have impermeable liners to maintain the appropriate separation to groundwater. And so here's an example of one that went in last year, right down near the water. And while these are winter photos, so the plants are dormant, so not the most flourishing green system at this point, you can see, I think, pretty nice aesthetic that can be folded in. Again, small footprint. This one had a Rain Guardian going to the focal point here with the domed overflow. This one, you can see the pretext, that bigger rectangular structure, because this one had a larger watershed going to it. So just a lot of different ways you can fold them in. Green roadways, another great thing to do. And this is where pre-treatment becomes really important. These are a project called the Downs in Scarborough, Maine. The mulch has only been dressed up once, and these systems have been in for almost 4 years. The Rain Guardian gets cleaned out 3 or 4 times a year, because you can see all this pine needles and all this material that gets there. And it's super easy to clean this than, again, trying to grab all that and disturb the plants as you work your way along. The only thing we found, though, as people start to fold things more into these green roadways, is that you sometimes get into a bit of a sticky wicket with regard to the vertical curb that you're trying to deal with. So, seeing we're not boxed, we're boxless. Well, what do you do if you have to drop off a curb? Do you use a deep curb? Now it's exposed on both sides. Is a plow going to tap that, knock it over? How's that all going to work? So we do have one little extra accessory that we added about 1.5 years ago now. It's called the Urban Rain Garden, and it's really a precast spread footing modular rain garden surround. So if you think about the idea of either bringing in a large box or having to cast something in place, this is a modular segmental system, 3 foot high or 4 foot high, 4 foot wide or 6 foot wide, with a spread footing either on one side as an L wall or on both sides as a T wall. And you can kind of build out the formwork or surround for any kind of rain garden or focal point, right? So in those real tight spaces and you feel like you can't get the slopes to work and you might be concerned about curb walls, this is another little option that you can add on and still fold in the Rain Guardian, still fold in the domed overflow, expanded our tank and things like that as well. All right, so the last 7 minutes, what I want to do is just go through a quick overview of kind of what it looks like to work with this system and how to model it. And most of that modeling happens in HydroCAD, which is a program that I'm sure many of you are familiar with and use for a lot of your modeling. The focal point is not in HydroCAD as like a chamber wizard type option. The R tank is, which is good, but for the focal point, there's too many variables to get that in there at this point. But we do have pre-set up nodes with a lot of the right components there. So if you are working on a system like this, you can reach out to us and we can give you that node and then kind of show you how to manipulate it to get it to work. But essentially, if you're using focal point just to treat and release, you're going to have your subcat going to a focal point only. If for some reason you have expanded R tank beneath, you actually model the R tank as a separate node. And the reason for that is you want to be able to model the 100-inch/hour discharge from the focal point into the R tank. And then usually the R tank will have its own outlet control downstream. So while they're directly on top of each other, we actually model them as one pond feeding the next. And again, we can kind of show you how that works. I'm going to pull up HydroCAD in just a minute. But essentially, you're going to have 2 storage inputs. You're going to have the cylinder of the focal point, and then you're also going to have the surface bowl to be able to handle some of that temporary storage. In today's example, the surface of the focal point, that surface of mulch, is going to be set at elevation 100. And And then you'll see here the focal point invert itself, I have at 97.75. So that's 2.25 feet lower. And what that represents is the 3 inches of mulch, 18 inches of media, and then the 6 inches of stone. That's 2.25 feet. So essentially it models all the way down to the point where it would drop into the R tank. If we're just treating and releasing, we don't even have to model the R tank because we know that R tank underdrain has enough capacity to send things on. But if we're doing a R tank, expanded R tank system, that's when we would kind of define the R tank storage from 97.75 down to whatever depth the R tank would be at. You'll see that in a minute. And then we also have two outlet inputs. The first is at 97.75. That is that 100 inch per hour. We essentially say exfiltration rate, but it's the primary routing. So that's that 100 inch per hour rate coming through the system, discharging to wherever we're going. And then in this case, I have a domed overflow that's set, you'll see at 100.5. So that's 6 inches above the surface. And again, that could be 6, that could be 12, maybe up to 18. In today's example, we're going to keep the temporary storage at 6 inches before we spill over. So what I'm going to do now is just pull up our design worksheet and then also our HydroCAD model. All right, can everybody see that design worksheet? Get a nod, Scott. Give me a nod. Yep, you can see this. See the worksheet. Okay, so in today's example, what we're going to do is assume that our watershed area is 25,000 square feet. So we convert that to acres for our worksheets, which I think is like 0.574 or something like that. We're going to assume that it's all impervious, so there's no pervious area, and then we have to work out our minimum focal point area. So the minimum focal point area, again, is at 192 square feet per acre. So if I take 0.574 and times that by 192, that tells me that my minimum focal point area is 110 square feet. Now what we're going to do is actually take that information, we're going to go back to HydroCAD, and then we're going to see, is that minimum area sufficient, okay? So scooping over to HydroCAD, can everyone see HydroCAD now? Yep, okay, awesome. So what we're going to do is just quickly set up a node here, and we're going to just call this subcat 1 for today, not a very fancy name. Again, we've got 25,000 square feet of area. We're going to assume a curve number of 98, and we're also going to assume a minimum TC of 6 minutes. Usually it's 5 or 6 minutes, depending on where you're working, just to get that set up. We're also going to look at our focal point, which again, from the worksheet, we think we need 110 square feet. Oops. So the way this is set up, again, we've got this 97.75 for the focal point invert. So let's take a look at that. So for now, this was set up as a 4x5, but I'm going to change that to a 10x11. Again, it doesn't have to be a perfect shape. We're just really trying to define the surface area. It can be whatever shape you want. You'll see that height of 2.25. So that's going to represent the area from 97.75 up to elevation 100. I'm going to allow exfiltration, and the reason for that is that's going to help me define that 100 inch per hour rate in a minute. And I assume some kind of aggregate void space of 20%. It's probably larger than that, but it's just an assumption, and it's a small area, so it's not going to help much with the volume. And then the surface bowl, so at 100, okay, we're going to, base area will go with 110. We're going to assume that the surface area is 100.5. So this is now modeling this area up at the surface. Void space is 100% because it's an open air bowl. And I want to make sure that I don't click allow exfiltration here. So I'm almost assuming that bowl area around the focal point is essentially paved. There's no losses. If we click allow exfiltration, it's going to allow that 100 inch per hour rate everywhere, and that's going to make it seem like the focal point is overperforming. On the outlet side of things, at 97.75, I have this 100 inch per hour design flow rate as primary, and constant velocity to the surface area. Little trick here I found from HydroCAD over the years. If you add a phase in depth of, say, even just 0.1, it helps calm the oscillations. So if you have a phase in depth of just 0, you'll get some oscillation warnings. We get the kind of wiggly worm hydrograph. If you put in this phase in depth of 0.1, it actually smooths out that hydrograph and gets rid of some of those oscillation issues. So that's just something to think about. Not even just a focal point, that's just a general kind of a tip. And then again, at 100.5, I have this domed overflow set, horizontal plane, so it's essentially a circumferential weir. I picked 18 inches in diameter, but you've got to come up with the right size for that and hit OK. All right, so now what we're going to do is link that up so that that watershed area is feeding that focal point. And I'm just going to make sure, oh, it's also important to make sure you use dynamic storage indication method so that you're getting the tailwater impacts of anything upstream from what's happening downstream. That's just a rule of thumb for any time you're modeling ponds or anything with detention. Rainfall event, I'm assuming a type 3 24-hour, and I'm using this 1.2 inch water quality storm for today. So let's look at the watershed first. If we look at that there, you'll see actually the runoff depth is 0.99, so that's telling us that that 1.2 inch event that Rhode Island uses is pretty good at predicting what a 1 inch runoff depth would look like. So that looks to be in good shape. And then we're gonna have a look at the focal point. So if we look at the focal point, just gonna expand this a little bit. You'll see that we've got a bit of a problem here. So that 110 square foot focal point, the peak elevation is 100.52, but we set the domed overflow at 100.5. So what that's telling us is, oh, and you can see that here, that secondary bypass is activated just by a little bit, but essentially we're not getting all that flow through the focal point. So this would not be a we're done kind of situation. We have to go back and come up with a better solution. Now we can do two things here, right? Easy thing is to say, all right, well, let's increase the size of the focal point. Let's go up to 120 square feet, 10 by 12. Let's see how that goes. We'll run it again. Let's take a look at the results here. Okay, good. So now we're below 100.5 for the peak elevation, and you can see the secondary flow is at 0. So this would be a good solution. However, 10 square feet of focal point adds cost to your system. So we could also say, well, you know what? I really don't want to spend any more money. I want to stay with that 110, square foot minimum system. But you know what? I think I can get a little bit more surface storage. I think I can get a base area of 200. I think it can be up to 700 by the time at 100.5 and maybe 1200 when I get to 101. And now let's see if that works. So we run through that situation. We'll say, oh yeah, great, same again. So now even with that focal point of that minimum size of 110 square feet, we have achieved the treatment of that entire water quality volume because we have a little bit more temporary storage. So that's sort of the process we generally work through. Obviously, I kind of practice this one in advance to work out this kind of situation. Some projects you have to go through 3 or 4 iterations before you come up with the correct solution. So if we go back to the worksheet now, we could now fill out the rest of it. So we could say, all right, we do need 110, or maybe we didn't have that room, so maybe we go with 120 here. We say it's approximately 10 by 12, or we could say, irregular shape in there. And then there's a few other things we have to fill out just to demonstrate that, yes, we did that 1.2 inch storm, whatever that water quality volume was, the temporary storage depth of 6 inches, and you're pretty much done at that point. The only things to then again check is, okay, this is more than a quarter acre, so I could either use a water quality manhole or I could use a pre-text. So what am I doing for pre-treatment? Is there a landscape plan? Have we reviewed the plan and done a letter for you? And are you using some of the plants from the plant species list? So that's kind of the process we work through. And just to close it out and then hand it back to my colleagues, you should be able to see my slideshow again. Is that right? All right, thanks, Scott. So that's that. And again, we can help a lot also with layout, sizing, sections, plans, these types of things. We've got a great engineering team who can provide design support and CAD layouts, for all these systems. Some engineers we work with like to kind of work with us collaboratively through the whole process. Others say, oh no, I got what I need. I'm gonna go do this and just come back to you for review. That's totally fine too. We also do what we call sketchbook. So if you're looking at a brand new site or you're looking to do retrofits in a certain location, we can come out and help do sort of like a windshield survey and come up with some ideas for you. I touched on this before, but should also mention we are out in the field too. So we produce quality submittal packages. We host our own pre-construction meetings to make sure that folks with systems like FocalPoint, RTank, and others know how the system goes in and kind of help with, provide site visits throughout those installations. any kind of closeout that's needed to post installation, maintenance, support, coaching, and things like that. And then, for my team, and I think Scott kind of operates the same way, we're really looking to not just, deliver products to the site and wait for a check to come in the mail. We like to get out and help. So if we can help with some of that site-specific support and evaluation, windshield surveys, vision casting for retrofits, we're the ones selling this material directly to the owner or the contractor. So we have very good budget pricing tools. We can turn that around for you very quickly, so you know kind of what you're looking at for your stormwater budget. And also like to help with the maintenance training, or we've designed a number of educational placards to help folks as well really tell the story of not just this is digging a hole and throwing something in the ground, but there's not only environmental impact, but the ability for these systems to have social engagement, community impact, and things like that. And we want to do what we can do to support that. So with that, I thank you certainly for tuning in to this portion of it. I'll hand it back to the presentation team. But certainly between Scott and myself and the teams that we both work with, are fully ready and able to help you with projects moving forward.
Thank you so much, Rob and Scott. That was a wonderful presentation. And I see that Scott's been firing away answers to your questions. It's time to move on to the engineering portion of this webinar. But if you do have more questions, feel free to put them in the chat, and we will have 10 minutes at the end for any remaining questions. So I will turn it over to Mark Hollis with Deprete Engineering.
Hey, good morning. Can everyone see my slides here?
Looks like you need to put them in presentation mode on our side.
Sure. All right, great.
Perfect.
All right, so good morning. So my name is Mark Hollis. I'm a project manager at Deprete Engineering. So my plan here today is to kind of take you through one specific application of the FocalPoint system at the site at 525 Killingly Street in Johnston, Rhode Island. As a firm, we've designed about 5 or 6 of these systems now. So between myself, Len Bradley, Dana Nisbet, and Ryan Schnepper, we're slowly becoming experts on these systems. And we're really starting to use these more and more, especially on these really tight urban redevelopment sites. Dana's with me here today. I think she was just mentioning she's going to just be using one of these on an upcoming site. She's also designed quite a few of these, and they really are a really good technology that we're starting to utilize more often. So just talking briefly here about the team. So with me here today is Michael Gazdaco. He's the Director of Construction and Maintenance for Colbia Enterprises. They own and operate the Seasons Corner Market brand. Michael is here to provide an owner's perspective of the system. He'll be available at the end to answer any questions. Just keep in mind that, while we've designed 5 or 6 of these, this is the first system that's actually been built. And it was really just turned online about a month ago. So he doesn't really have a full idea of what it's like to own and operate one of these just yet. He can certainly kind of answer some of the questions. Colbia and Michael are great clients to work with. They are very flexible. We've used a jellyfish filter in North Attleboro. We've used Stormcrete in Warwick. Like I said, we've used these focal points on quite a few sites now. So as a designer, it really is a benefit to have a client that's willing to kind of work with you and is open-minded about the options out there. The next member of the team that we just heard from, Rob Woodman. I first met Rob about 10 years ago when I was working for the City of Worcester Sewer Department. We installed about, I think, 10 tree box filters and one FocalPoint system over at Indian Lake with my buddy Dave Harris, who I believe is on the call here. So hi, Dave. And I remember just being very impressed back in the day just about how dedicated and knowledgeable Rob was about these systems and just the stormwater industry as a whole. Last week I reached out to Rob just for a quick technical question. He got back with an extremely detailed response in about 5 minutes. So he's a great ally to have on your team. Part of the DEM certification process here is you need to reach out to Rob and Lauren and that team to have your design reviewed. So that might seem like a burden, but in reality, that's an absolute benefit because it's really good to have another set of eyes on your designs, and it also kind of provides you a level of comfort that you're designing it correctly. Last member of the team I'd like to give a shout out here too is the construction team, which is James B. Lanigan Construction. Sean Pacheco was the manager, or the supervisor for this specific job. Those guys do just a great job on all these sites. They really are difficult sites just due to the really tight nature of them. So just shout out to those guys for doing a great job as always. So looking at this one specific site here in Johnston, Rhode Island. So we have an aerial image on the left. The existing site prior to redevelopment was a 2,300 square foot building. On the right side of the page here, we have kind of just a general subcat split of kind of the pre-development flows. So the whole front of the site drained out to Killingly Street undetained. The whole rear and kind of right side of the site flowed to a wetland in the rear. It's important to note that there was really just no water quality treatment at all on the site prior to redevelopment. So, just by coming in here and kind of redeveloping the site, putting in new product piping, putting in new USTs, a new canopy, all that stuff provided already an environmental benefit. And the fact that we're able to kind of, increase the water quality treatment certainly helps as well. The ultimate receiving water body for this site is the Woonasquatucket River, which has a TMDL for fecal coliform. So just keep that in mind. So here's the redeveloped site. You'll see this red boundary here is our new kind of water quality catchment area. So everything within this red boundary is going to receive water quality treatment via this FocalPoint system. We still are letting a little bit of water go undetained up to Killingly Street. And that's just because, the site does meet the redevelopment standard, so we're able to do that. BMPs on the site include deep sump catch basins. We have a water quality bypass manhole. We have an oil water separator. We have our FocalPoint water quality system. We have a lined R tank system for peak flow mitigation. And finally, we have a level spreader in the rear of the site. So just zooming in a bit on the stormwater treatment system here. So the entire, water quality storm will flow through this. It goes through the bypass manhole. It'll go through the oil water separator, which provides, any kind of spill containment. If there were to be a spill, it's all going to get captured in there. That's also going to do the job to remove just TSS in general. So the water quality storm will flow to the FocalPoint, as you can see in the section view here. So this pipe here, this kind of 6-inch pipe, is this one you're looking at there. So the whole water quality storm will go to the FocalPoint and then, drain down at that 100 inches per hour into the R tank system. The larger storms will start to overflow this concrete weir within that the bypass structure. And then that water is going to flow directly down here into the R tank system. I just added this hydrograph here for the 100-year storm, just to show that we're getting about a 90% efficient bypass, which is excellent. I mean, that just it prevents kind of undue or unneeded wear and tear on the FocalPoint system if we're able to bypass those larger storms effectively. Finally here, we have this level spreader, which reduces the flows to below, I think 1.5 feet per second, just to ensure that we have just non-erosive flows heading out to the wetland. So, why FocalPoint on this site? Essentially, as I said, it's just a really tight redevelopment site without much space. We could have looked into a jellyfish filter, but that's, just a lot more expensive than this option. And as Rob was saying, kind of, bioretention rain gardens just require a bigger footprint. So this really did the job for us. And, as we're finding out, this system does the job on really a lot of these redevelopment sites. So here's some pictures of the FocalPoint system. First one here, we have the R tanks going in. This picture here is of the FocalPoint. Over here, we get the FocalPoint actually installed on top of the R tanks. So again, the smaller storms are going to flow directly to the FocalPoint system, drain down into the R tanks. The larger storms are just going to go directly into the R tank system. Here is the almost final product, still pending some plantings here that again be installed as soon as kind of the weather allows it. And the last picture here is just the level spreader, and you can see the wetland in the back here, which is the ultimate discharge point. So as far as post-construction maintenance, as part of the DEM certification, we're required to enter into a contract with a certified maintenance provider. In this case, we're using Stormwater Compliance LLC. So during the permitting stage, all we did was provide just a signed letter of intent to enter into this contract agreement, and we should be actually executing this contract this week. So after that 2-year maintenance, interval there, the owner will take over the maintenance of the system. Site-wide, the site-wide O&M includes street sweeping, semi-annual inspections and clean out of the drainage structures, the oil water separator and the R tank. And you got the gas station here has a pretty robust emergency response plan. So generally, that's kind of all I had just to describe the system. I'm happy to answer any questions.
Thank you so much, Mark. There was a question that came through from Shannon. Advice or strategies for getting local DPW buy-in, especially for long-term maintenance, if incorporating these in public ways / lots, etc.
Yeah, so I mean, I would say you can really lean on the fact that Rob and his team are very much involved in the design of these, and especially with DEM, you're kind of required to enter into that maintenance agreement with a certified maintenance provider. So having those two things, you can kind of hand those to a DPW and say, hey, look, we're absolutely going to learn from the pros on how to maintain this thing. So I think that should give them a pretty good level of comfort there.
There were also a couple questions that came through about how you clean out the R tanks once they're installed.
So I believe the R tank, the clean out, I think you probably use a vac truck with just a 4-inch hose. And then, once there's inspection ports. So if there's any kind of sediment in there, you can take a look. There's a certain threshold. I think it's about 2 to 3 inches. Robbie, you can probably speak to this better as far as how to exactly clean these out.
Sure, yeah. No, I mean, the nice thing is when you're using it in conjunction with a FocalPoint, that the size particle that could get through the FocalPoint media is so small that that's really not going to have any kind of deleterious impact on the R tank. So you're getting such a high level of filtration that the R tanks, honestly, really protected. Obviously, then with the bypass, putting in that filter bag is also that protection for the bypass. So if you have that filter bag in the bypass and you've gone through a FocalPoint, the expectation is that the R tank really shouldn't need much maintenance at all over time. I think inspection is right, just like Mark said. Keep an eye out for any of that buildup. Now, when you do R tank on its own, just as a storage system, then obviously you've got to have robust pre-treatment. And we also have maintenance rows with circular plates that you can jet certain lines. But from the FocalPoint side specifically, the R tank should be very well protected for an extended period of time, just based on the level of filtration you're providing upstream or up directly above it.
All right, I think we have time for just one more question before we move into the short owners portion. What was the cost, I assume, just of this one implementation?
That's a good question. I don't actually have the answer to. We can certainly provide that, but I just don't know that number.
All right, that's all I'm seeing for now. Thank you so much, Mark. And I know that
Thank you.
Larry had a quick slide, and then we'll have some more time for questions.
Good morning. My name is Larry Colantuano. I manage a couple of safe harbor marinas here in Wickford. And just this past year, we installed the system that you're seeing here in the slides. It's kind of interesting how it came about. We started working with an engineering firm who didn't necessarily share our concept of how we wanted to use the property. I voiced that frustration with a friend who's also a member here at the marina, and he's also a PE. About that same day, later that evening, he forwarded me all the FocalPoint detail that we then shared with this engineering firm and said, hey, take a look at this. We'd like to see if we can implement some of this into our plan, because we view it as a space-saving accommodation, which was very important to us because we use all of this property to store vessels in the winter, and we need our parking in the summer. We just didn't want to have an endless rain garden consuming too much of the property. So we're pretty happy with how it's turned out. It's definitely a new product and something that the installers are, a little green on. Fortunately, the folks at Ferguson were on site during the construction of both of the focal points, and it went really well. That's as a result of all this, we're now looking at this technology to be used at other sites here in Rhode Island. We have a site over in Quonset at Allen Harbor that needs a lot of redevelopment. And one of my colleagues is currently working with an engineering firm to figure out exactly what we're going to do on that site. That has to go in front of the QDC before we can get in front of DEM and CRMC. But we're happy the technology exists, and also glad that DEM's endorsing it and behind it as well. And that's about all I have. If anybody has any questions or wants to see one of these in action, come on by. We're at 65 Reynolds Street, North Kingstown, and you can see it live in person.
Larry, I'd also like to add that for this project, it was slightly unique. So they lined this system because it's obviously so close to the water, and they also had check valves installed to prevent backflows into the system. So that was a unique aspect of this install. And thank you again, Larry, for speaking.
If I could ask a question, one thing that came up during the presentation was the outfall. And we do have the backflows, but the backflow only works to a certain degree. We got a 100-year storm where our property is overcome with seawater. I'm wondering what the effect of the seawater will have on the system. Will there be any negative or adverse problems with the media, or are we just looking at replacing mulch and cleaning it up after that event?
Rob and Scott, I don't know if you want to tackle that one at all, but I would imagine that the salt might affect the plants a little bit.
Sure. Yeah, if Scott wants to jump in too, that's fine. Yeah, I mean, from a planting standpoint, we have the only place that we've seen the plants struggle is sometimes when you're in that like heavy salt environment, you get that regular salt intrusion. And so, usually a more basic palette of more salt tolerant plants are used. compared to most of our typical site development projects, the plants, go until they're done absorbing nutrients, and then, they kind of get a little bit more dormant. Scott, any thoughts? You're a bit more of a geek on the science side with regard to media and what chloride could do to that over time.
Yeah, it's a certainly good question, Larry. I think your question could apply to any vegetated or green infrastructure BMP. But typically salt water is a lot less saline than the salt water coming off a parking lot that's been salted in the wintertime, right? That's pretty high salinity there. So I don't, as far as the underdrain, that's a polypropylene material, that's not going to corrode or be impacted whatsoever. The bridging stone, the media, from a material standpoint, won't be affected by salts, right? It's really just the root zone and potentially the vegetation at the surface that could be impacted if you have long periods of inundation, which just I don't think we can really design for those types of things. Hopefully with dilution from stormwater, from rinse water, maybe at the site, just fresh water hose, you're going to be probably fine in long term. But worst case, if something dies, you just have to take it out and replant it.
Perfect. Thank you.
Thank you so much, Larry, and thanks to all of our presenters. We have time for just a couple more questions. There's one that came through. Were you seeing any exceedance of metals concentrations prior to installation of your stormwater system? And if so, have you seen a reduction in metals concentrations in your discharges?
I'll let Scott jump in again about on the metal side of things. Metals is something we've certainly got some data on and continuing to evaluate. Not for any of these specific sites, so maybe Scott, you can talk about metals in general.
Is the question about Larry's site in particular, or is it about the system?
I think it might be, but they might be interested in a general answer to that question as well.
Yeah, we do have metals removal data. Obviously, we do a really good job of removing fine particulates, so metals that are bound to particulate surfaces, maybe because you have a slight a little bit of organic matter in your particulate mix, so that typically hangs on to heavy metals that come off our brake pads and our cars and any other types of metal surfaces, right? So we do pretty good for particulate bound heavy metals, copper, lead, and zinc in particular. We do have a test facility out in at a Navy facility with dissolved zinc and other dissolved heavy metals, and we've actually got an activated layer of media beneath the focal point that's doing really well for dissolved metals removal. But yeah, for particulate metals, we do pretty well. We have field testing data to support that.
All right, I think we have time for one more question. Norman asks, what is the expected lifetime of the system?
Sure, I'll take a stab at that first. So we don't list any specific lifespan for the system. A lot of the lifespan is going to be geared towards maintenance practices from my perspective. So, the media should continue to sort of regenerate itself somewhat in terms of, the plants are uptaking that nutrient load, continuing to sort of restore the media's ability to get its work done. If you have good pre-treatment upstream as well, you're going to be trapping a lot of that sediment load that is going to also prevent that material from clogging. That being said, my general guidance when I'm talking to engineers and designers, developers, municipalities is that, look, if you're going to replace that mulch layer, say once a year with good pre-treatment, maybe it's a little less frequent, whatever it may be. Over time, as you're raking off that 3 inches of mulch and putting new mulch back, you're going to start to spoil that crust where the mulch meets the media. And so, my general rule of thumb is assuming that maybe after 5 to 8 years, you're going to replace, say 3 to 6 inches of that media. Maybe. Have we done that anywhere? No. The only system we've actually replaced is one where there was a substantial oil spill and a lot of things had to be rebuilt. So that had really nothing to do with the focal point. But now there probably will be a point where some of those plants get to their point where they've done all the work that they can do. They've uptaken all of the nutrient load they can, and so you might need to replace the plants after 5 or 6 years. Again, haven't really seen that yet, even though we have systems in New England in the ground by 8, 9 years now, maybe even 10 years. So there's really no prescribed replacement period or life period, and I think the better job you do pre-treating and maintaining, the further you can extend that.
All right. Thank you all. We're at the end of our time here. Thank you all so much for attending. Thank you to our presenters. I will give a quick plug to our website on behalf of the Stormwater Innovation Center. You will also receive a link to the recording if you registered, but our website is stormwaterinnovation.org. And at the link I just sent in the chat, you will also be able to view the presentation there once it's available. Thank you so much, everyone. Have a wonderful day.
Oh, Rebecca, one more thing.
Oh, yes.
If you want to just leave this open for the 5 minutes, I can continue to answer questions since I haven't answered everybody's questions yet.
Sure. If folks want to stay on and for a few more minutes,
yeah,
that works.
Yeah, I only have 3 or 4 more to answer, so just want to make sure. Thank you.
Sure.
everyone. It looks like those last few questions are mostly covered, so I'm going to go ahead and close out the webinar. The questions can be sent to all the presenters in a report, so you'll be able to look at them after the fact. Thanks.
Great. Thanks, Rebecca.
Bye.